In Lesson 1, we will solve inequalities. The use of the calculator is not allowed in this section. We'll start out with the entrance slip, and I'd like you to complete numbers 1, 2, and 3A. As we solve number 1, we would add 7 to each side, giving us 2y is equal to 18. We then divide both sides by 2, and we should have gotten y is equal to 9. For number 2, we should have subtracted 5 on each side, giving us negative 3y is equal to negative 12. Then we would divide each side by negative 3. We end up getting y is equal to 4. And then for number 3, there's a couple ways to start it, but what I'm doing here is I'm starting by subtracting 2 on each side. That's going to give me negative 3 times the quantity y plus 4. Again, if I subtracted 2 over, that's going to give me 9. I divide each side through by negative 3. I ended up getting y plus 4 is equal to negative 3, and then I subtracted the 4 over to give me y is equal to negative 7. Again, you could have distributed this first and combined like terms. Either way, we should get y is equal to negative 7. Now, with that in mind, we'll move on to inequalities. So you're going to notice that these relate very closely to what we just did, but these ones are inequalities. So go ahead and solve 1, 2, and 3. So we want to keep in mind that when we're solving inequalities, one thing to watch for is that if we ever divide by a negative, we need to flip the direction of the inequality. In number 1, B, when we start by adding 7, we should end up getting 2y is less than 18. We divide both sides by 2 and get y is less than 9. Into B, we would subtract 5 on each side. That gives us negative 3y is greater than negative 12. At that point, we have to divide both sides by negative 3. And this is where we end up flipping the direction of the inequality. Again, anytime we have to divide by a negative, it does flip the direction of the inequality. The answer to 2B should be y is less than 4. For number 3, again, if you start by subtracting 2 on each side, you would get this step right here. Then if we divided both sides by negative 3, we would get this step right here, keeping in mind that because I divided by a negative 3, that inequality has to flip directions. Final step would be to subtract 4 on each side, which gives us y is greater than or equal to negative 7. Okay, and then in 1C, 2C, and 3C, we have very similar problems, but here we're solving for y. So in number 1, what we want to do is start by adding 7x over. Now this time they don't combine, so we have to leave that as 7x plus 11. Then we want to take and divide both sides and every single term by 2. And so we get just y, we get 7 over 2x plus 11 over 2. And that would be the answer. For number 2, here, we're going to start by subtracting 5x on each side. Again, we cannot combine negative 5x and negative 7, so you leave them separated. Now we divide everything through by negative 3. And again, that means that this inequality is going to switch directions when we do that division. So negative 5 divided by negative 3 is 5/3. Negative 7 divided by negative 3 is 7/3. And then for number 3, again, I'll start by subtracting the 2x over. That means that this negative 3 times the quantity y plus 4 stays. I end up with negative 2x plus 12 on the right side. If I divide by negative 3 next, I'm going to end up with just y plus 4 on this side. I did divide by a negative, so I have to flip the direction of the inequality. Negative 2 divided by negative 3 is positive 2/3. We have x, and then 12 divided by negative 3 is negative 4. And then finally, if I subtract the 4 over on each side, then I've got a negative 4 and a negative 4 combining to give me negative 8. So same type of problem here. We're solving each of these inequalities for y. So you can go through and solve each of those inequalities. In number 4, when we're trying to isolate the y, we would start by subtracting over 3x. So here I've got 2y is less than negative 3x plus 6. From there, I would divide both sides by 2, giving me y is less than negative 3 halves x plus 3. For number 5, I would start by subtracting 7x on each side, giving me negative 4y is less than or equal to negative 7x plus 56. Then I would divide everything through by negative 4. That is going to flip the direction of the inequality, giving me y is greater than or equal to 7/4 x minus 14. Then for number 6, if I start by adding 2x over, I get negative 5y is greater than 2x plus 50. divide both sides by -5, and I am going to end up getting flipping the inequality, so y is less than -2/5 x minus 10. And for this next part, we're going to determine if the point represents a solution. So we did this with equations the other day. What we're doing here is plugging in our values for x and y, and we're seeing if it gives us a true answer. So if it's a true statement, we're going to say yes, it represents a solution. If it's a false statement, we're going to say no, it does not represent a solution. So when we do this with number 7, plugging in 3 and 2, we end up getting 3 times 3 minus 2 times 2 is less than or equal to 12. Well, 3 times 3 is 9, minus 2 times 2 is 4. Since 9 minus 4 is going to give us 5, and we know that 5 is less than or equal to 12, we're going to say it's true, so yes, this represents a solution. And we'll do the same thing for number 8. So here we've got 3 times 2 minus 2 times -5 is less than or equal to 12. From here, 3 times 2 is going to give us 6. -2 times -5 is positive 10. 6 and 10 combined give us 16. And so we have 16 is less than or equal to 12. This is not a true statement. This is false. So that means that no, it does not represent a solution. And then for number 9, when we're plugging these in, I've got 3 times -3 minus 2 times 4 is less than or equal to 12. 3 times -3 gives me -9. -2 times 4 is -8. These two combine to give me -17. So we're asking, is -17 less than or equal to 12? Yes, it's true. So we're going to say yes, that does represent a solution. And we do the same thing with these next two problems. So we're plugging in the 1 for the x value and the 5 for the y value. So if I've got 4 times 1 is greater than 5 minus 1, I'm going to get 4 is greater than 4. Now, that is not a true statement, because if it said 4 is greater than or equal to 4, then sure, that would be a true statement. But a 4 is not bigger than a 4. They're the same. So this is a false statement, so no, it does not represent a solution. And then for this next one, if I'm plugging in -7 and 3, here I get 3 is less than 2 times -7 plus 20. So I get 3 is less than -14 plus 20. Therefore, 3 is less than 6. Yes, this is a true statement. So yes, it's going to be a solution.